In the last session, if you remember, I think we covered, we're primarily looking at, overall in the last couple of sessions, we're looking at high availability and what are the options we have in Azure. I think just a recap, I think we looked at various options like availability set, availability zones, and what are the SLAs offered by Azure in this, and also the good practices that need to be followed for high availability. I think as a continuation to that session, I think today let's look at the load balancer, because this is also one of the recommendations when especially when you're talking about multiple VMs. So load balancer will go hand in hand along with, for example, scale sets. Scale sets, if you remember, we discussed in the last session, where it will help you to scale up the resources and scale down the resources whenever there is the load based on the demand, it will scale up or scale down. But in addition to that, load balancer is also equally important category where the load balancer will, the architecture, it will stay in the front, and every request that we get from the client, so the load balancer will decide which VM is free and accordingly route the traffic. So that is the purpose of the load balancer, and that this also will come under the category of high availability. But logically speaking, this is a component that will come under the networking category in Azure. This is not a compute. This is under networking. So just to, I mean, the VM scale sets, for example, is creating a VM. So that will come under compute category. But the load balancer is a networking component in Azure. So yeah, I think let's go in deep to understand load balancer in this session. So typically the load balancer will start with this will be the front facing in a typical architecture where all the internet traffic. I mean, there could be other components before this also, but generally once you're inside your virtual network, inside a virtual network, most probably load balancer will be the first component where it will receive the public traffic. So the public, generally the load balancer which is facing the front will be called as public load balancer. Why it's called public? Because it requires a public IP. So that's why it's called public load balancer. Yeah, which will primarily internally route the traffic to the other VMs. And it is also possible that we can also have an internal load balancer as well, which will route the traffic internally. But again, why it is internal? Because this doesn't require a public IP, and it also it deals with only the private IPs of the VMs only. So that's why it's internal and it will not have a public IP. But the first one, which will just definitely will have a public IP associated to a load balancer. So yeah, so typically an architecture for including a load balancer would be generally most of the web applications will be multi-tier architecture. Will have multi-tier architecture. So generally the web tier, which will be generally exposed with a domain, and that will be exposed on a load balancer, public load balancer. But for example, if the application is talking to a database or middle tier or a business tier, so these components need not be exposed on public internet. So there will be an internal load balancer that will manage the load. So, but the main purpose of this load balancer is primarily to it will continuously monitor the VMs behind the scenes, and based on whichever is idle or having better resources, it will route the traffic so that even if one goes down, it will automatically identify that something is down, and it will route the traffic to others. So it will basically, from the name itself, it is just balancing the load of various components. So mostly it will be VMs, so which will transfer the load. So just coming back here, so Azure Load Balancer will, as I mentioned, it distributes the load, and it also operates under the layer 4 category of OSI model. So layer 4 in a OSA model is like the networking layer. So it's considered the networking component. So it operates on a layer 4 category, and there will be public load balancer and internal load balancer. The public load balancer will provide outbound connections for the virtual machines, and it is accomplished by translating their private IPs to the public IPs. So generally, uh, all this load balancer will have the private IPs of all the VMs. So it primarily communicates via the private IP. Uh, so that way it is more secure. So we have only one public endpoint, one public IP endpoint. The rest are all private. So that way it is more secure. So I mean, in typical architecture, it is always in the cloud world for security purpose. It is good to minimize the public IPs as much as possible, because public IPs are prone to like it is available on internet, so anyone can access it. So generally, it is good practice to minimize the public IPs and use the private IPs as much as possible, so that way it is more secure. So in this architecture, except all these things will be working on private IP except the first one, which is having the public IP. The rest of all the communications between the rest of the flows is all through private IPs only. So yeah, that is what we're talking about here. And internal load balancer will from the name itself it is private, so it will not have any public IP. But yeah, it will again balance the load of all the VMs behind the scene. Any questions here?
No, good.
Okay.
Continue, please.
Yeah. Then again, why load balancer? It is primarily load balance the internal and external traffic, and also it generally increases the availability within and also across the zones. So the VMs that we're talking about, these VMs could be either within the zones or it could be across the zones. Again, coming back to the availability set or availability zones. So this VMs could be within a data center or across data centers. Like that's why it's availability zones. So yeah, I mean, load balancer supports both, uh, and yeah, generally this it configures the outbound connectivity for the Azure virtual machines. Again, it internally uses health probes primarily to monitor the load balancer resources. So it will look at the it will keep on pinging these resources and check the health of these VMs. So at any given time when a new load comes, it need to know the status of that VM. Is it alive or it is not reachable? So it keeps on checking the health probe. Using health probe, it will keep on monitoring the health of this VMs. So this health probe is a common component which is used in most of the Azure components, which primarily looks at monitoring stuff. So health probe is also used in Azure Load Balancer, and also it employs the port forwarding, which is also one of the common concept to access the virtual machines. And also this also enables the IPv6 of also it supports IPv6 also in this for the VMs. And of course it uses Azure Monitor. Azure Monitor is a common component which is primarily to monitor the metrics. So yeah, load balancer uses Azure Monitor, and also it uses multiple ports, IP addresses, or both. So it uses ports, IP addresses, or combination of both. You can use both. So I mean, for example, to be very specific on the ports, I mean, in one VM there could be multiple ports. So let's say database could be on 3306 for MySQL, for example, or if you have a web application, it could be, for example, on 8080 port, or another web application running on a different port. So it could be mostly in one IP. There it is possible to install many or expose many ports. So you can explicitly provide IPs and ports combination. If you want to load balance a specific application inside a specific database inside, you can expose it by with the combination of IP and ports. right? And then move internal and external load balancer across Azure regions, and also the load balancer TCP and UDP flow on all the ports simultaneously using HA ports. Yeah, so basically, if you look at this TCP and UDP flow is what is the important keywords that we need to remember. Azure load balancer is not for HTTP protocol. It comes under networking, and it is comes under OSA level 4. So level 4, for example, in OSA model is only for networking components, not web components. So web is like when it's a web protocol, it's a layer 7 in OSA model. So layers, so that is that covers HTTP and HTTPS. I mean, typically when the protocols that you use in for anything that you access on browser, for example, like you use HTTP. So this is not for HTTP traffic. This is for TCP and UDP traffic. So it is primarily the networking protocols is what is covered. So for that is one. There are other products which in Azure space which will cover specifically the HTTP component, which will go through in the following slide. So yeah, but this is primarily for TCP and UDP protocols. What is covered? Yeah, again, exam point of view. If someone, if there are questions like what components do we generally use for load balancing the TCP or UDP protocols? The answer is Azure load balancer. Yeah, just another thing is this also supports IPv6 also now, and also it primarily relies on the health probes. So these are the common questions that we mostly get. So this Azure load balancer, if you go further, so it is there are various. I mean there are types in this. The standard and basic. These are the two common categories in most of the products. These are the two basic classification. Um, so here, if you look at what is the difference between the standard versus basic, so standard, I mean, basic is like, I mean, starting point. I mean, it will be definitely cheaper. Standard is a bit costlier because it has more features. If you look at the differences, I mean, the backend pool points, endpoints, sorry, backend pool endpoints is primarily, this is where the VMs that you're talking about is generally this is called backend pool. For example, how many VMs you are associating is this is a pool. So it's called as backend pool. So this backend pool can have one VM or many VMs. One VM doesn't make sense. Minimum two it makes sense. I mean, there are two or many. So that is the backend pool endpoint. So here in the basic category, only availability set or scale sets VMs are only considered. Here in standard, any VM is considered. I mean, meaning the VM could be an individual VM also. So it need not be an availability set or a scale set. It could be any VM. It need not be. I mean, VMs, for example, you can create a single basic VM, for example, one VM if you associate, so it doesn't require to be an availability set. But with basic, you need to go with either availability set or scale set. So yeah, you need that prerequisite for basic, but in standard, it supports VMs without availability set also. And the pool size, meaning how many instances of VMs that you can associate in a backend pool. So in standard is 1000, whereas in basic is 300. And availability zone support, yes. And again, the VMs spread across data center. So it is S, and whereas here it is availability zones are not supported here. And diagnostics, it is multi-dimensional metrics in that you get. I mean, you get a lot of metrics covering various dimensions, but here it is basic metrics because it's basic model. So and it doesn't even look at monitor. Azure Log Analytics is another kind of monitoring component, which is primarily meant for only to get the data from logs. So you get only the data from log analytics component, not the full-fledged Azure monitor. So which means yeah, you get only basic stuff. That is what it means. Then HA port, high availability ports. So it is supported here, whereas it is not. And secure by default yes and no. SLA 99.99% for standard, but here there is no SLA here. So and health probe types for the endpoints, TCP, HTTP, HTTPS, but here it is TCP and HTTP. So this is for the, I mean, don't confuse with the UDP protocols which I mentioned. This is for the VM, the probe types. I mean, the probe is like it will monitor your, in the VM you can deploy an HTTP web application or HTTPS web application. But this is talking about the probe types and the protocols for it, not the data packet that you're sending, which comes under the networking category, which covers UDP and TCP protocols. So here we're talking about the application inside the VM. So this can be HTTP or HTTPS also it supports. Yeah. Right. So this is a difference from that. And yeah, before going to the demo side, so some basic terminologies which are used, I think we already covered some of them. For example, here front-end IP configurations. So here, I mean, generally the load balancer will have two components: the front end and the back end. The front end that's where you associate a public IP or private IP, because just to go back. So this is two sides of it. One is this is the front end, and this is the back end. I mean the front and back of the load balancers. So the front will have an IP association. The front end generally will have an IP association. It will be public IP or a private IP. On the back end, you will generally associate to a pool, and so the back end is primarily we'll talk about the VMs. The front end will be IP, public IP, private IP. Here, private IP is applicable, as here it is public IP. But back end is like the more VMs. So coming back, yeah. So that's what it says. So the front end IP configurations will be either public or private IP. For back end, it will be generally a group of it's a pool. So which means you'll have a group of VMs, a group of servers. And other terminology that we need to know is the health probe. I think we discussed. It is more about it monitors the health of the backend pool, and also this will have load balancing rules, which decides basically the traffic distribution to the backend pool. So, like what should be the rule to transfer the traffic? So that is what decided by load balancer rule. So then inbound NAT rule, binding of binding a specific IPR port to a specific instance in the backend pool. So it will have some rules which are specific to load balancer and inbound traffic. So which is a combination of IP and port, and also the outbound rules like control the outgoing traffic. So generally every component will have inbound traffic, outbound traffic. So you can configure rules for both inbound and outbound. So that's what it is. I think this is once you see the demo, you'll understand this better. And just to give a comparison, in Azure, there are at least 4 load balancer categories. I mean, they are all. I mean, generally they're termed as they all generally meant to manage the traffic. So they all come under the category of broader category of load balancers, but the purposes are different. So what we're discussing is the last one, the Azure load balancer, which is generally a regional level, meaning load balancer can be used within a region, not global. Like multi-region support is not there in load balancer. So if you're looking for a global, so then there's another product there. So load balancer, the scope is regional, and the traffic it supports is non-HTTPS, which is primarily the TCP and UDP. So that is the category where Azure load balancer will fit. So talking about regional traffic, and also you're talking about a non-HTTPS traffic, HTTP/HTTPS traffic, which is like TCP or UDP. So that's why it fits under the level OSI level 4 model, which is a pure networking, not HTTP. But if you're looking for just a comparison, because we're going through these components also, these components also for in the following section. So just to give a quick sneak preview, basically this the same category. If you're looking for regional, and if you're looking for HTTP or HTTPS pure web traffic, there it is called, the product that is called as application gateway in Azure. And if you're looking for a global traffic, I mean, we're talking about connecting VMs across regions now. So that's why it's called global. So the VMs could be across regions. So in that case, we want to connect them. Then this traffic manager plays a role. I mean, if we just remember the disaster recovery, also we discussed this traffic manager. Right, I mean, so it is like one region completely down, the traffic should be transferred to other region. So for that use case, I think we remember we discussed the traffic manager. So yeah, traffic manager is similar to load balancer. The difference is it is global, and yeah, of course, same protocol wise it is non-HTTPS, so same to load balancer. Front door is like I mean the Route 53 where it is global. It is supporting HTTP or HTTP web traffic. So yeah, so that's why, yeah. So we have 4 products, and for people who who work with AWS, there we have only these 4 products were merged into 2. For global, it is just Route 53, which supports both, and for load balancers, so that is which is regional. So we have load balancer. I mean, the name is also called AWS load balancer. So internally, they have subcomponents for HTTP and non-HTTP. So, but it is one product. But in Azure, they branded as 4 products rather than 2 products. So yeah, so that is what. So basically, in exam, this section could be a bit tricky because they'll give a scenario and ask you to suggest which load balancer would be an option for this kind of a case study. So in this case, this table will be helpful. So if they're talking about non-HTTPS traffic, then non-HTTPS is like load balancer and a traffic manager based on the region where it is. If we're talking about web traffic, which is HTTP or HTTPS, then we're talking about application gateway for regional and front door for global. Yeah, just keep this in mind while, yeah, this is a summary of all the 4 products under the similar bucket of load balancing. Okay, so let's move further. Yeah, I think this also I saw in some questions which are coming in some sample exams which I took. So this hashing algorithm is something how load balancer pushes the traffic. So once it gets a client request, it is using some logic and it is routing the traffic, right? So what is that logic? So the logic or algorithm that uses is 5 tuple hash. So the 5 tuple hash algorithm is like it uses a combination of the source IP port, destination IP port, and the protocol. So protocol is it could be TCP or UDP. So if you take that, so more or less you get a unique record. For example, here if you see the diagram, so this VM will have a private IP. Private IPs will be unique. That itself is a unique combination. But if you combine that with a port, that will be even more unique. And if you combine that along with the source from where you're getting the traffic, So that will be even unique, and of course, if happening protocol, it will be 100% unique. So, it uses this algorithm internally. Again, that is, it is not exposed outside, but yeah, it's more about internal features. It's knowing about internally how this works. So, yeah, so this fightable hash algorithm is something which is used internally. It is a combination of the source and destination IP ports and protocol. Okay, so let's go to demo now. So what I'm planning to do is uh, we'll create VMs and we'll basically route the traffic. We'll create a load balancer and we'll associate the VMs to it and see how the traffic goes across. So that's what we're going to see. Let's go to Azure. For any questions before that? Uh,
No.
okay.
Skill.
Okay. So okay. I think just to save some time, I don't know whether this makes sense. Okay, let me create a new VM itself. I was using it for other purposes. Maybe I'll create a new VM. So basically, what I'm planning to do is I will create two VMs and let's use that for our load balancing requirement. So what I will do is I will create a new VM. I'll create this sorry availability set. We create a new availability set. Prepare the fault domain update domains. So basically, I'm creating two VMs. One VM will be in one data center. I mean, one rack with the data center, and other VM is in the same data center but in a different rack. So I'm planning to create, yeah, in this diagram, if you look at, I'm planning to create probably two Windows VMs, Windows 2000, maybe 2019, and then Windows Server 2019, and then we'll try to associate. Maybe instead of three, maybe let's create two, and associate a load balancer to it, and associate a public IP. And try to hit that load balancer where it internally routes the traffic to, and then also let's also deploy some probably IaaS server on this machines, so that way we have some web server running, and when we hit it from a public IP, we should route the traffic to the web servers between these two. I mean, load balancer decides when to route the traffic, but we'll route the traffic to these VMs, to the IaaS servers which is deployed on these VMs. So if we come here, so okay. Okay, so here, since we're also looking for web, we also want to enable port 80. Okay, this is fine, this is fine. So that is VM. So while it is creating, let's go further and create one more VM. Basically, try to first create the VMs and then want to create a load balancer and associate these two VMs there. Okay. So just curious, what is the VM name that I gave? Okay, doesn't matter. Okay. So VM4 I'm giving, 3 and 4 I'm giving. 1 and 2 is already there in my, so I have deleted that. The availability set. Okay. And this is Windows programming data center. So yeah, I'm taking all defaults for rest of it. So yeah, let those VMs be them be creating. So let's also go and create a load balancer in the meanwhile. So let's create a standard. Yeah. Let's create a new IP for this. This is where it is asking for a public IP name, um, and it is asking for availability zone. Let it be zone redundant. So basically, I created a load balancer. This okay. I gave the name as yeah, let be more clear. VM. I should have given a VM3 name, but I missed to give that. So by default, it created with Azure user as the VM name. But here I gave a VM4. So basically, Azure, you can associate this as VM3 and this is VM4. So okay. So what I'll do is I will go to this VM now. Probably I will connect to this VM and install IIS server. So it is connected. Let me connect the other VM also. So basically, this is a server, 2019 Windows server edition. So yeah, in this I want to install a public IaaS web server. So the idea is it is equivalent to like I'm running some web application on this machine, um, so that it would run on some port 80, and I will try to hit that from outside from load balancer. So that is what my idea. So I'm planning to install IaaS on this. So this is the IaaS server which I'm trying to install on this machine. Let this run. Connecting to other room. Let's use probably the other VM that I already have. It's installing instead of happening. Let me try to use this VM one. Okay, this I think I already installed. Good. Yeah, this is already having uh, IAS already installed on this machine. Which is good. Uh, Let me quickly connect localhost here. This works. Yes, so this is what. Uh, let's do the same thing here. So this is working. Um, so this let's try to hit the same from using this public IP of these machines from outside. So here, probably networking side, this port is allowed. This RDP is allowed. This is working. And this is also allowed. 179, 34. Oh, Azure user. Okay, very well. I think Azure user one is what is connected. Azure, not EM4. EM4 is not working. Azure user is also. Yeah. So this works. Uh, the not sure why this is working. Let me double check. Here. Okay. So yeah, let's do this. So here VM two is what I think we already have. Let's use that VM2 and Azure user. So these are the two VMs that we can take where this IA servers are accessible from these two virtual machines. So this is VM2, 116 is and Azure VM, Azure user is also VM. So, for example, yeah, 21 is working, it is from Azure VM, and 116 is also working. Okay, so these VMs, I think, yeah, so let's I can close this one. Yeah, so is this. Yeah, and let me also connect to VM2 virtual machine. Okay, so this also connects. Is good. So let's just for I think I just want to show you that I want to make some changes here so that you can differentiate this VM versus that VM. I mean, when I'm trying to hit from outside from load balancer, I want to make some small difference here and there. So probably I'll create some sample changes to this. So generally, the screen that you're seeing here that will be generally deployed in the C iNet pub www root. So this is where your HTML that you're seeing outside is coming from here. So probably let me edit this. we have print this in the top. Yeah, so this is printing here. So similarly for the other, also I will make a quick change. This is VM2. Good. So basically from, I could have two screens to differentiate now, just to see from where the call is coming. And now I'm doing it from a local laptop. This is VM2 and this is Azure user. Okay, good. So now, so I have two applications running on these two VMs. Now I want to use the load balancer and detach this. But yeah, one important thing is that this VMs shouldn't have the public IP while associating. I mean, otherwise the purpose of this itself is defeated. So we should not have. I mean, for testing purposes, I created, but these VMs shouldn't have the public IP. For example, these VMs, I create public IPs, but I think it shouldn't have public IPs. Otherwise, the purpose is defeated. So we should disassociate the public IPs for these VMs and then attach them to the load balancer. So I will quickly go now to the Azure user and go to networking. I'm removing the public IP for that. I mean, if you see here, you see a public IP for this machine, right? So now I'm trying to remove this public IP. So it will have only the private IP, not the public IP. So I'm going to delete that. Go to the networking area. So this is where you generally just give a background. I think this, if you want to delete a public IP, it will be in networking section, and in that networking section, network interface card. So this is where the network interface component is what associates an IP to a VM. So this is the network interface card for this VM. So I'm going inside this. So this is where I have the IP configuration. So this is the IP. This is a public IP. I'm saying this as the associate. Save. Same thing. If we go to the other VM also here. Again, go to the networking. IP configurations. This is saved. So yeah. So while this is while this is running, yeah, I think. So basically, just to summarize here, we created two VMs and we installed a web component inside these, like IaaS web server, and they're running on port 80. So when you give localhost or just IP alone, you are getting that home page. Right? So, and we have to differentiate this page versus this page. So we just added a text so that it would print the VM name. So yeah, now we have two VMs ready with IIS web components running on port 80, and we are removing the public IPs for it. Now let's just we also just created the load balancer, but we didn't link these two. I mean, we didn't create a backend pool for this. So next step would be to create the backend pool and tell that these are two VMs that will be there in the backend pool. So that's what we're going to do now. This will take some time. Uh, this is done. Yeah, it takes some time. Let's go to the load balancer. So this is the one that this is the one that I created. So if you look at this is where I was telling there will be uh, we currently we don't have a public IP, so we need to create a public IP for this. Yeah, okay, so it's already there. The public IP is already created. So and also this is the if you go to the backend pool, now backend pool is empty. So we need to link these two VMs that we created. So let's create that backend pool now. Backend pool name, some name. So if you see here, so we are getting a add button, virtual machines. So this is added. So with the other VM. Oh, okay. You can attach only the virtual names that are in the same location or in the same virtual network as load balancer. Must have standardized here. Okay, sorry. I think the other VM is the VM2 is not coming here. Um, but ideally we should. I think it is not having probably the public IP or something like it's not missing. Maybe let me double check once. Just can attach only the VMs that are in the same location and on same virtual network as well. Okay. I think it is same location. Okay, let me go check. Just come. The other one is VM2. Also, no, the other VM is in Azure Usage. Okay. I think need to figure out. I think it will take some more time. Maybe I will do one thing. So I will add this, but I assume that you will have one more VM that you can associate. Now I can add that here. So basically, I should be getting the other VM also, but probably I made some mistake in selecting a wrong configuration for this IP or a virtual network. So two combinations that could go wrong here. But I think assume that it is already there. We have two VMs also selected here. So that is where you create a backend pool. Okay, I will take a look at this, but I think more or less the process is the same. So basically, once you connect to this, what you will do is you will directly go to the front end IP of this, and you hit this. This is where I mean, this all works together. So if you hit this is your public IP. So and if you hit this by default, the uh, I mean, it will either load to VM2 or Azure VM, Azure user VM. So either of these two, it will shift the load between these two VMs. Actually, that is what I want to show. But I think probably I think I will take this. I'll take a look at it and probably I will do this demo next time. But yeah, I understood the logic. I assume, right? So I made some mistakes on that. Um, sorry, I couldn't continue this. I will take a look at it and probably next session I will give this. So, but yeah, let's continue with the session.
So, Sham,
Yeah,
one question. Like, so the logic you said is like based on some tuple, right? Like 5 tuple. Is it? Is that
yeah,
the
but that is something
way?
internal. We no need to. I mean, it
Internal.
is not exposed outside. Uh, for
Mm-hmm.
example, those details is something which is not exposed to outside. If you look at the configurations, so those are all very those details will be something
Yeah.
internal for us. If you look at the
So
health
even as a
floats,
cloud
yeah.
administrator, right? Like, so there is something network reliability engineer, right? Or
Mm.
site reliability engineer, SRE. He
Mm.
also cannot change this algorithm or like tweak, fine tune that load balancing. It is, how do you know? Like, it is because whatever they give you, that's what you adopt, right? Like, is there a possibility to fine tune it or no?
As far as I know, I don't have any options here at least. Whatever is there in this is what the options have, right? I don't think that you can change anything. But but I can take this point. I mean, maybe I'll double check this and let you know. But as far as I know, it is not possible to change. Probably, yeah, I think that's
Yeah.
why it says internal because I don't see any options here in the settings to do that. So change any algorithms configuration. So again, this is again internal logic that is exposed, but I don't think you can change it.
Yeah. Usually it is too complex. I think they don't let you
Yeah, yeah,
change it actually.
correct.
Yeah.
Yeah, even exposing.
The traffic manager lets you do it, right? The outside one, like
Yeah,
Route 53 equivalent. That will they let you do that.
yeah, probably. I mean, this is something which is internal. So at least I'm not seeing that option here. So I assume it is not there. But I can double check once again. Let you know.
Okay.
Yeah.
Continue.
So in
Okay.
AWS, they have three levels of load balancer, right? One is the ELB, elastic load balancing, which is kind of legacy, and they have a network load balancing that is the futuristic, and there is the application load balancer, which is what they are recommending right now. But here, I don't see too much of those kind of options.
Yeah. I mean, here it is there. I mean, if you look at, I mean, for load balancer is what is a product which is global. Inside that we have in AWS we have as I said, like network load balancer, which is this. It's called as Azure load balancer. So this is covers non-HTTPS traffic, which is TCP and UDP. So this is equivalent to network load balancer in Azure. And application load balancer is application gateway here. Uh, it covers the web traffic. Okay. So these two are clubbed into one product called AWS Load Balancer. I mean, even though it calls network load balancer and application load balancer, these are all sub under uh, a, a broader product called load balancer in AWS. So, but here they are two separate products, not one product, but they have two separate products. Um, so that is what this part. Um, but if you look at Route 53, Route 53 is a global product which supports both HTTPS and a non-HTTPS. So this is also clubbed. I mean, in AWS, Route 53 covers both. But here again in Azure they split this into two. front door, which takes care of HTTP, HTTPS, and traffic manager is for non-HTTPS. So yeah, so summary is that we'll have a mix of both. Route 53 covering Azure, so Route 53 is covering front door plus traffic manager, so which covers the global traffic basically, both HTTPS and non-HTTPS. So that is here it is separated. This HTTP and yeah. So that is what this, and here it is. These two are load balancer. In AWS, it is just AWS load balancer. Of course, internally they have network as a separate and application as a separate subcomponents inside. But broader, it is just one product in AWS. But here it is split into two: application gateway, covering HTTP, whereas this one load balancer, which is non-HTTP. Both of them is the scope is within regional, within probably the network. So yeah, so this is what the summary of the load balancer. Maybe in the probably the next session I will give a demo of this correctly. I think somewhere I don't waste time again. Right, and then now let's go to the next component, which is the equivalent of the same category. What is our load balancer, which is covering non-HTTPS, but the scope is regional. But now the same ditto is traffic manager, but the scope is global. So let's see that. So again, this also covers the non-HTTPS part. So that is what this traffic manager is. This traffic manager, so this is similar to, it is global. So you can relate this to Route 50, but just that it is now for non-HTTPS traffic of Route 53. So if you have to relate it to the AWS. So the traffic manager is primarily this one being a global, so it should think not at IP, it would be at a DNS level, meaning the domain level. So this traffic manager, the scope is primarily a DNS-based traffic manager. So that is a difference between the previous one versus this. So traffic manager being a global, this will be at a DNS level. So DNS-based load balancer, and this will enable you to distribute the traffic optimally to services across global Azure regions. As you know, there are multiple regions across the globe, right? So this will distribute the traffic across regions. Now we're talking about global, so across region communication, not within two data centers. We're talking about two different regions, VM1 in one region and VM2 in different other region. So we're talking about distributed traffic between these two, for example. So that is what this is. So typically this is the scope of the traffic manager. I mean the Azure boundary. So before this, like user from a browser, let's say he will type some domain name which is hosted on Azure. So probably let's say we deployed an application. I mean, this time was contoso.com, right? So this is, let's say we deployed this contoso A, contoso B.com. So two different domain names. So when you hit from a browser, the domain name contosoa.com, so generally it will go to some DNS server which is registered for. I mean, there are a lot of DNS servers available. Like for example, even if you type google.com from a laptop, it internally, google.com is a domain name, but internally the browser need an IP address equivalent to google.com. So it will go and recursively search in a DNS service and tries to find the IP for google.com, in this case contoursa.com. Now the DNS service will be returning you an IP address. So, and a DNS service also finds that google.com or contoursa.com is associated to some traffic manager. In this case, when you try to hit contoursa.com, it knows that it is registered with the traffic manager of Azure, so it will route the traffic to that Contoursa to traffic manager, and this guy will internally route the traffic to whatever application that is associated to that page. For example, if you take contoursa.com, if you want to show the home page of the contoursa.com, so it will whatever the resources required for that, it will, for example, it's a VM or a web app, whatever it is, so it will link to that resource. So only difference is that now we're talking global. So this VM or a web app could be across regions. So, but the traffic manager can intelligently identify that. So that is the perspective that we need to look at for traffic manager. So, and the features, if you look at, it primarily increases the application availability. So that is where we're talking about now. Even if one data center or one region goes down, we are not impacted. So it is even higher, giving higher availability of the failovers, and also it will improve the application performance as well by using traffic manager. Basically, it directs the traffic to the endpoint with the lowest network latency. So this performance also plays an important role. Where it has a lot of rules that you can configure. So, for example, you can say least. Take the geographical consideration and then based on the geographical consideration, for example, user that is sitting is let's say in India. So this traffic manager will route it to India region rather than US region, because if we associate to US region, the latency will be higher to send the response back. So it can consider those aspects as well, generally to reduce the latency aspect. So it can intelligently route the traffic accordingly. And also it can perform service maintenance without downtime. So it will like directing traffic to alternate endpoints during maintenance. So that will help there. And also it also look at the combined hybrid applications. So for example, it supports multi-cloud. I think there's a question in the last session that which component supports a multi-cloud setup. For example, application. The other application, it need not be within Azure. It could be somewhere else in a different cloud, or it could be on-premise also. But traffic manager can talk to everyone. The other component could be a multi-cloud or be a hybrid, which means like on-premise setup. So it supports both. So and this is also one important exam question. So if you're looking for if one of the component is a multi-cloud or a hybrid, so and if you have to route the traffic, then option is traffic manager. And also it distributes the traffic for complex deployments. Primarily, it can use there are a lot of traffic manager profiles that you can configure. So and also it can I will tell you what is nested traffic profiles, so you can use nested traffic profiles and multiple traffic routing methods. You can use a combination also. That is what it is, multiple traffic routing methods. I will tell you what is traffic routing methods in success slides. But you can mix and match the traffic routing methods, and also you can nest them also, like one like combination of traffic routes also can be considered. So it can go nested way of also of associating. So yeah, so these are the advantages of the traffic manager at a high level. So one thing that you need to know is that this is a global. and this can it can work with not only Azure. It is a multi-cloud and hybrid also it supports, and yeah, it has a lot of routing methods which we'll look at, but based on the routing rules that you configure, it will work based on that. So, for example, if your network latency is your is a requirement, then you can configure that routing rule as consider network latency as input. So it will apply that rule and will route the traffic to the respective resources. So yeah, so it is global. So that is the difference between the previous one versus this one. But both works on non-HTTPS, not for HTTP, not for web traffic. This is for networking traffic. Yeah. So yeah, I think a lot of content here, but yeah, it is. But how this works, I mean, this is very interesting actually. So it is typical to any DNS concept. So domain naming service. So it's a typical concept. Basically, what Traffic Manager uses is internally it registers the endpoint. Okay. So there will be a lot of endpoints. So for example, endpoint is nothing but a domain name. So contosa.a.com, contosa.b.com. So likewise, it will be some domain name. It registers all the endpoints. So what is endpoint? Endpoint is nothing but an internet-facing hosted service, either sitting inside or outside Azure. So and this traffic manager primarily uses DNS as a concept, the domain naming system, to direct traffic, and it is based on a couple of methods. One is traffic routing method, and also health of the endpoint. These are two things that will be considered. What is the traffic routing method? I think I will in the next slide I will tell you what are the various traffic routing methods available. But it will use traffic routing method or rule that you configured, and health. So these are two things it will decide. It will consider, and based on that, the traffic will be routed across. Okay. I mean, just before going to this diagram, let's understand this. For example, we have a domain name called partners.contoso.com. So the CNAME in this, I mean, in DNS there are a lot of concepts called CNAME, alias, and also this. So this is the CNAME for this case is which is configured in the traffic manager is contoso dot. I mean, everything you associate in traffic manager will have trafficmanager.net. So so this let's say you have three endpoints in this. The Contoso Traffic Manager .net is having three endpoints like Contoso US, Contoso EU, and Contoso Asia. So, but any given time, only one should be active. So that is the job of the traffic manager. To the end user, someone is giving partners.contoso.com. Of course, it will go to the traffic manager, and the traffic manager has three options to make. Between one of these three, it has to route the traffic to US or EU or Asia. So, but only one should be returned out. So internally, each US, EU, and Asia will have a separate IP associated to it. So a domain is only for outside people. I mean, for general public, but for all the products like Traffic Manager or even the general internet works only on IP addresses, not on the domain name. Domain name is only for the human to easily remember that. But yeah, everything is associated to an IP address. So yeah, I'm just telling this because this you can relate it with the flow which I explained here. So now when a user is trying to hit from a browser, when he's trying to hit partners.contoso.com, okay. So what happens is internally, I mean, this is not in the boundary of Azure. This is general internet, which is like the domain naming system that is available. So whenever you hit a domain name, google.com or partners.contoso.com, so that is a domain name. So it should identify what is the IP address of this. So that is where this DNS service will, recursive DNS service will help. So if you look at when you hit a browser, so the client sends a DNS query with name partners@contoso.com. Let's assume that, and two, which is like the DNS server should know uh, using the recursive DNS, it will find the name servers and return the CNAME record that points to the contoso.trafficmanager.net. So this DNS service would need to know whether this is deployed in Azure or it is deployed in, for example, some other place. So it need to know. So it is having all the mappings. So given this domain name, it will translate that to contoso.trafficmanager.net, because every traffic manager equivalent guys should publish their domain names to DNS service. So this guy will know what is the internal translation to be done. So yeah, so basically since this guy knows that contoso.trafficmanager.net is the value, it should be published. So it will route this traffic to traffic manager. And now, so recursive routes to traffic manager. Now, next step is now the flow is control is in traffic manager now. So this guy should now apply the rules, the traffic routing methods, and the health. These two it should consider, and it should route this to either one of these components which are deployed across region. So it will look at health checks and will make a call. So so now now your traffic manager identified based on state or health or traffic routing parameters. It identified what is a resource to be called. Let's assume it is calling EU as by applying the rule. So this EU Contoso EU cloudapp.net should go back to the DNS service again, and this recursive DNS now returns the DNS A record, which is the IP address of the EU service endpoint. And 7 is basically now the recursive DNS returns a single DNS response to the client. And 8, now user will be redirected to the IP address of the EU traffic. So basically, once you hit a domain, right, this is all something running behind the scenes. So you will not know if you hit google.com, it is associated finally to some virtual machine running in Google infrastructure. So it is fetching the resources from that VM or some Docker container or something. But behind the scenes, this is how the flow goes. It will first go to DNS service. DNS service will identify what is the traffic manager or equivalent to that, and routes the traffic to that component. And traffic manager will decide by applying all the. Let's assume this traffic manager is having many. Then it has to pick one. US, EU, Asia. It has to pick one. Then it will look at health checks and other parameters, and it will fetch one. Let's say U. Again, it will give you the IP address of that. So again, browser will get the IP address of it. Basically, if you look at user initially in point 1, he has given the domain, but from DNS he got the IP address with the translated IP address, and now browser is directly hitting the VM's IP. I mean, these are all something browser will take care behind the scenes. But one thing to remember is that browser and DNS services will cache this this data, the IP address and the domain name. It will cache it so that whenever a similar request comes, it will not go through this round trip. So it will try to get the data from the cache. Only if the data is not there in the cache, only then it will go try to find the IP address. Okay. So yeah, sorry, was it clear? Do you want to explain more, or let me know? Any questions?
So once you get the IP address, right? Like,
Mm-hmm.
so this is general internet way of working, right? Like basically you try to get an
Yeah.
endpoint, right?
Yeah.
So so you're not still not like we are not into the load balancing thing, right? Like so, maybe I'm getting ahead.
Oh, no, no.
So if
This is, I mean, I mean, assuming that the traffic manager has three options to select, it is fetching you one, and this three is all same. I mean, it's a replica. Okay, one in US, one in EU, one in Asia. So now traffic manager will intelligently make a decision based on the rules that you configure to configure that. I will tell you what the rules that you can configure in the next slides. But it will. So you gave the domain name. It can now traffic manager can return the IP address of either US or EU or Asia. So that is where traffic manager's role is.
okay.
So you could mix and match with the internal load balancer along with it, right?
Yeah. I mean, this could be in a VNet. So it could be again
Yeah.
internally. It can
So
go to a in load balance, internal load balance.
that is how mostly people use, because you still wants to have the load balancer within your side of the VPC or VNet or whatever it is, right? Yeah. So, but you get best of both. That
Yeah. For example, see this diagram, right? So we're talking about this regional high availability, right? But if you look at this traffic manager is internally calling the internal load balancer here. Um, right? So it's a mix and match. So you're using traffic manager in combination with the internal load balancer.
so one of the beauty thing is this internal load balancer could be of Azure or AWS or whatever it is, because it is cross cloud thing, right? So that way internally whatever has to happen, it will happen, but the outside people doesn't have to know which cloud they're hitting.
Exactly.
Shyam, I have a question.
Yeah.
You mentioned it actually in one of the slides. I think if I remember correctly, basic or the standard. This one.
Mm-hmm.
Yes. This actually. So based on your configuration, does it select actually the high availability? Meaning, how does it work? The high availability. How does it choose how does it act actually, depending on your configuration, because you have the premium, what do you call it? You call it a basic and standard here, because one is it kind of a diagnostic here, or is it for load balancers? This is one of the configuration, what you shown here.
Yeah, I think we're mixing two things. So one is this load balancer is for internal. I mean, this is inside a VNet. Okay. So the one that we're talking about, traffic manager, is outside this box. I mean, it is a global candidate.
Does it work hand in hand with? My question was, does it work hand in hand with the load balancer?
Yeah,
The traffic
it
manager.
works. Yeah, it is. So it is. For example, that's what the previous question from Srini was telling the same thing. So so this is what this is what we discussed, that it could be a basic or a premium. So yeah, so let's assume it is premium. So or basic doesn't matter. I mean, it is some load balancer. It is uh, it is getting the health of the VMs. Again, the scope of this load balancer is within a VNet. Okay, so it is within a VNet box. Okay, so and it is within a region. Okay, the scope you can understand the scope here. The scope is restricted to within a region and within a VNet. It can't go across regions.
Across it. Right.
Okay, but if you want across regions, then traffic manager is your solution. So this can go to this side all, and this is region one, region two. It can go both sides and take the health which is better, and then it can route the traffic accordingly.
So, and one more thing, I mean, I heard one terminology called the gateway ring. So, is it very similar to traffic manager?
I will not heard of it. Gateway ring, right? Maybe I will take a look.
Yeah, plus, yeah.
Yeah.
Because from one of my friend, but I'm not sure. But
Okay.
I wanted to ask you. Yeah.
Sure. I will take a look at it.
Yeah, thank you. Yeah, thank you. I think thanks for clarification. Yeah.
Yeah. Okay. So I mean, this is the crux of it. I mean, internally, there are a lot of things running. I mean, we are just hitting the domain name, but internally, behind the scenes, the flow is going to multiple servers and doing multiple hops to get the IP address of the final destination. So at finally, our browser routes, once it gets a translated IP for the domain name, it just does connect to that resource directly. Um, so, yeah, that is the power of this traffic manager. It can route across. It can go. The resource could be within Azure or outside Azure, or it could be on premise. Uh, what it need to know is just an endpoint. I mean, the endpoint can be anywhere, and that is the only prerequisite for traffic manager. And you need to tell what on what basis I need to uh, route the traffic. So, so which is called as routing method. So you should tell the routing methods. Of course, it monitors the health on its behalf, so you don't need to tell that. But you just need to give some health parameters, like how many milliseconds that it has to monitor. But primary is this routing method. This is the core concept on which this traffic manager routes the traffic. So that's what we're going to see in the next slide. So
Yeah.
there are a lot of
Sham,
yeah.
one thing. So I think you're coming to that, but so you said like the IP is cached or like the DNS name is cached and browser caches it or the computer caches it, right? Once it is done. So the next time when it tries to reach it is going to go directly to that IP.
Hmm.
What if that site has gone down or something, right?
Hmm.
So does this again go through the same thing again, like or like the
Yeah,
traffic manager automatically knows?
correct. I mean,
Oh, it.
yeah, it caches. So the DNS service will do the same functionality of checking the status, monitoring the health. So basically, it will first go here and it will check whether the health is that valid. So if it is not valid, it will go through the process. But if it is valid, it will. I mean, it is already having the cache data, so it will return the data and then it will directly go to it. So this guy will manage the. Will keep on checking the health of that IP.
Hmm.
So generally, this is yeah. It depends on the a lot of DNS servers are there across the globe. So it is, and there are a lot of DNS service algorithms are also there. Recursive algorithm is the most used algorithm in this, but there are other options are also there. It depends on what. What is the DNS service algorithm that is configured there? So it depends on that. I mean, this whatever I told, this is the latest where it can monitor on its own. But the older servers or other algorithms may not do this job. So yeah, it depends. So you will get a different result based on the algorithm that is configured here.
Okay.
Okay. So, yeah, now let's go to the routing methods. So if you look at again from exam point of view, this routing methods are important. There could be questions given. They will give a scenario and they'll ask you what is the routing method that needs to be applied in this scenario. Kind of a questions you'll see. Um, yeah. So there are a lot of rules are there. Example, I mean priority, weighted, performance, geographic, multi-value, and the one more is subnet. So these are the six, I guess. One, two, three, four, five, six. Yeah, six. Yeah, six. So six routing methods are there. So again, this is logical. I mean, it's nothing complex. I mean, the priority. I mean, you have basically, you have three, for example. Same case like US, EU, and Asia, right? So you need to pick one. Okay. And so, what is the logic? Just common sense. Like you have three, and you have to give one. So, what is the logic that you apply? and they give me one out of the three. So for that you have a lot of options. So one option is priority. So basically you can say um, so select priority when you want to use a primary service endpoint for all the traffic and provide backups in case the primary or backup are not available. So basically, if you look at, if you see here, this is the crux of it. The rest of it is all same. So this is a primary, and you can tell out of three, one is primary, and the other two are failovers. Okay. So it will always check first primary. Uh, Only if primary is down, basically after giving the priority. So always it will hit primary because priority is one for it. Only if the priority, if it is degraded, it will go to the next priority 2 or next priority 3. It is very common. When you select you give a priority, if you don't know anything, give a priority number. So based on priority number, it will route the traffic. So that is the simplest way of giving it, but just like no nonsense. Like if you don't know anything about it, this is the best way. Priority 1, 2, 3, and go by that. So next option is weighted. Basically, you can give weightage. For example, US you can give. I'm just giving same US, EU, and Asia. So you can give weightages for it. So based on the weightages, it will route the traffic accordingly. So so that is this weightage concept. Basically, it distributes the traffic either evenly or accordingly to the weights that you define. So so that is this weighted option. Third one is performance. So this is based on basically the geographical endpoints. Like when you have endpoints in different geographical location, you want end users to use the closest endpoint, which is it considers primarily the latency into consideration. The lowest network latency, whichever is that, it will route the traffic to that. Uh, for example, this West US, North Europe, East Asia. So if you see here, so 15 milliseconds, North Europe is 75 milliseconds, and so it will obviously take the least one, least priority. Wherever least milliseconds is there, that will be considered as a final return. It will consider the latency as the input for giving the result. And this option is geographic. Geographic is basically um, where the origin or user is. So based on the origin user, it will route the traffic. For example, if the origin user, let's say you configured same Germany, Asia, and rest of the world. You configure like this. If the user is let's say from Germany, it will be routed to Germany. Or if the user is uh, probably uh, probably a country which is in EU itself, let's say France. So I assume France is closer to Germany. So if the traffic is coming from France, it will still route to Germany because that is what is closest. Different Asia is not the closest to France. Germany is closest to France. So it will route to endpoint one. So it uses the geographic uh, like origin points geographic location. It will consider that, and based on it will route the traffic. So if it is, let's say, India, obviously it will go to the Asia profile. So for example, so you can also here this is what I was telling is the nested profile. Um, you can also mix the nested profile in this, wherein um, Mexico, Asia, again, you can have a sub endpoints also. So you can put another rule here, for example. So this rule need not be at one level. It can go at multiple levels below. So that's where this traffic manager will intelligently route to the respective resource. And this is multi-value. Multi-value is primarily it primarily considers IPv4, IPv6 address as endpoint, and when a profile when a query is received, all healthy endpoints are returned. So it returns more than one actually. So if you look at, let's say this traffic manager is having two IPs, so it will return the both the IPs. But if the whichever is healthy, so this IP is healthy, it will return that. This IP is healthy, it will return that. So, and this multi-value traffic routing, it allows you to get multiple healthy endpoints in a single DNS response, and primarily this will enable the caller, that is a client-side retries with other endpoints. For example, caller can, if there are multiple, if the site is down, for example, the client can do a retry to the second value. So let's say two values are returned. So it can return two values. So first the client browser will route it to the first IP. Let's say the first IP is down or for some reason it's not accessible. It will route you to the second option also. So because it is multi-value. So and also this pattern can increase the availability of service and probably reduce the latency associated, because again it is multi-value. So generally the multi-value is a good combination to consider, because it will look at the health parameter and also it returns more than one. So that if one is not accessible for some reason, it will automatically route you to the second one. So it always gets that advantage of combination. That is multi-value. And then next is the last one, which is subnet. So this subnet is something which is recently introduced. It will primarily look at in which subnet you are. Subnet is nothing but the networking. I mean, you can create a subnet inside a VNet, right? So that is what we're talking about. Subnet traffic routing method, primarily to map the set of end users' IP addresses to a specific endpoint within a traffic manager profile. And when a request is received, primarily consider it will return the one map for the request source IP address. So if you look at it will primarily, if you see the users, the traffic manager is others are there here, and East US is there here, and North Europe. So when traffic is coming from a particular IP which is associated with Northern Europe, it will, because IP is there. So based on this IP, you can tell if the IP ranging from this to this, you route the traffic to this subnet within, for example, Northern Europe. And if any other IP the traffic is coming, then route it to East US. So basically, it is looking at the IP address of the origin, and based on that, it is having the subnet also. Subnet is nothing but a network, the VNet subnet. So the subnet IP address also it will consider, and then it will route the traffic. So that is what this combination is. Right. And I think I mean this is summarized, right? I think it is we have various routing methods. Most used, if you look at, generally everyone will consider performance, because this is I mean everyone wants the page to be returned faster. If you don't know much about the location or any other things, this is the default that can be considered, like performance as an option. But if you know about the geographical, I mean, if you once the system is there and you have last 1 year of data, then you can, let's say, if you know the geographical usage of your site, like from which location you get to the US or Europe, then you can also consider geography as an option for you. And also this multi-valued subnet or something which is newly introduced. So this also can be used. But weightage, again, this is also an option. And priority is generally not much use unless if you don't know anything. If you can simply do something without knowing anything, then priority is an option. Generally, it's not an option used in production mostly. So generally, it is used performance, and geography is most commonly used. Weightage, it depends. In some cases, weightage also will be considered. Yeah. So basically, when traffic manager is deciding it where to send the traffic, it will configure when you create traffic manager, you create this routing method, and you will tell which routing method should be used. It is the input that you that we need to give. So based on that, it will apply that rule and then route the traffic to the respective location. Right. I think this is other additional features. If you look at, it also has endpoint monitoring. It can because of the health checks that are available, right? So it has health checks option. So because of health checks, it can decide. It can monitor the health of the endpoint. So endpoint monitoring is also an option that you can consider. Then it has integrations to all the Azure integrated endpoints. Azure, I mean, VM will have an endpoint. For example, storage will have an endpoint, like various Azure endpoints. It has integrations to all the Azure endpoints. It knows all the Azure endpoints. Also, it can apply the nested endpoints logic, and also it can look at from the monitor, Azure monitor. It can also know the traffic views also. So you can also see the traffic views in live. And you can if you go to the monitoring section in this page, you can also see the traffic, how the diagrammatical format. You can see how the traffic is going live. So which is a new integration done in this. And then real user measurements. You can also measure how the user traffic is coming and from which location it is coming. So you can see everything live. So all these things are all available, and of course metrics and alerts also are all there. So yeah, so this is the product about traffic manager. We don't have time now to go to the demo, but I think I will try to cover this one and the other one which we missed today. So we'll cover these two in the first thing. Let's complete the demos and then go to the slides in the next session. Sorry, I think too much of theory today. So any questions? A lot of theory is there in this content. So yeah, that's why I have to start this. Any questions here? Traffic manager. I mean, if we compare this with the Route 53 in AWS, so we also had a similar functionality in Route 53 also. So, if you attended AWS, we covered this.
It wasn't this detailed, right? Like in Route 53. It's just.
Yeah, I think these concepts are there. But only thing is, it may not. It had, I think, 4 or 5, not at least 6 here. But yeah, it is all there even in AWS. It's all. I think it's. I could relate that it is exactly ditto, not even a variation here.
Yeah.
The subnet is something I don't remember seeing it. This multi-value was also there. So subnet is something which I see is a bit different. Yeah. Yeah, I think if you don't have any other questions, I think we can disconnect now, wrap up here. Yeah.
Okay.
Yes,
Okay.
this is a good discussion, man. Yeah.
Yeah.
There you go.
Yeah. Okay, guys. Right there. Take care. We'll see you next time.
Thank you.
Bye-bye.
Thank you.
Yeah.
Thank you, guys.
Bye.
Thanks, Sham.
Yeah.
Bye.
Thank you, Sham.
Yeah. Bye-bye.
Bye. See you
Bye.
next week. Bye.